think some of the issues around air vehicles, and I think honestly most of them are true for ground vehicles as well. Ground vehicles have a little bit of an advantage in that nobody really wants a little RC car driving around the Soldiers Field Road. What they want are the bigger vehicles. They already have safety standards. So that's easy to do. But a lot of the other things in terms of autonomy, perception, GPS-9 navigation, interaction with other drivers, these are still huge and hard problems. And Google and Nissan and Toyota and a lot of the other big companies are making progress, but it's a ways away.
So thank you very much. A short follow-up. So you mentioned a number of technologies. Which ones are you focused on in your lab, and which ones are you most interested about?
Well, that's a good question. Well, so GPS-9 navigation is still one it's been part of my research portfolio for a while, as I think you know, and I'm going to continue to do that. I made mention of laser rangefinders. I think the laser rangefinders have been a crutch for robotics, both on the air and the ground, and so I'm really interested in really low-cost vision-based perception. I think I am actually interested in the integration with the bigger airspace, both on the air and the ground. There's a lot of other people flying around and driving around. And I am very interested in being able to talk to those other aircraft, be able to perceive those other drivers on the ground, understand what their intent is, and react accordingly. We do this all the time as drivers. Like you see a car and it doesn't have a signal on, but you know it's about to turn left into the parking lot. How does a robot build that model, and how do you take the appropriate action of slowing down and letting them cut across into West Garage? Same thing with aircraft. How do you understand when air traffic control tells you to go into a holding pattern because they've got to bring a 767 that's low on fuel in ahead of you? That's a hard problem and very interesting.
Very good. Our next question is for both Christopher and myself. So I'll let Christopher go first. Chris, it's not always clear what the military is doing with their technology. Can you offer some examples of unmanned aircraft technology that can be transferred to civilian use in the near term?
All right, thanks, Bill. So the regulatory environment is one of the challenges for transferring to civilian use. So we haven't been able to see, because of the regulation, what all is going to transfer. But I mean, we can look ahead to just to kind of try to figure out, some of the things that will transfer. I'm going to talk. Well, the regulation is a challenge, but I'm also going to mention another challenge too, which is to get to the civilian market. The price point of the technology has to be quite a bit lower, and so for the government funding, the defense funding, the technology that's developed for that. A lot of the trade-offs are around very high reliability and very, all environmental conditions, and it drives